Hi there, hires. Welcome to another video. This one is looking at problem A4 from the intro programming tasks. Now, you should have by now been working through generating code for problems A1, A2, and A3. And if you've not done that, I recommend that you do it because it makes it much easier to kind of combine code together or combine some of your code together to generate your answer for A4. Now, we're just building it at the moment like a National 5 program or a National 5 level program, in that we've got no subprograms and no data flow between the subprograms. That stuff will come later. But by building up these different solutions, although it becomes quite lengthy sometimes, it is actually really good practice, and hopefully you should be able to it should help you identify repeating code or code that would be better if it was separated out later on. Again, we're focusing on two's complement. This is to give you more experience in understanding the two's complement process, which is you're representing a negative number in an 8-bit binary sequence. What you got to do is you take your negative number, let's say it's negative 10, you work out what the positive value the value of the positive version of that number is, so positive 10 in binary. You then flip the zeros to ones and the ones to zeros, and then you add a binary sequence of 0, 0, 0, 0, 0, 7 zeros and a 1. And if you combine together those two binary sequences, so the flipped one and the 0, 0, 0, 0, 0, 0, 0, 1, then you will end up with a binary representation of your negative number. Now, as important things to remember is that the leftmost binary digit of the 8 bits, if it's a 0, it's a positive number. If it's a 1, it shows it's a negative number. And this allows it to be added together or used in calculations on the processor. And it's really quite easy for the processor to do this because it doesn't have to store things and run through multiple steps. So what we're going to do here is I'm going to start from scratch, but what you should be doing is starting from your program created in task A2 and attempting to implement the following design. So I'm going to copy this design and I'm going to paste it into my new replit. So here is our empty replit just now. Okay, you might have a bit more code to start off with if you use task A2, but let's look at each step in turn. So the main steps, step 1, 2, and 3, think of that as your main program, whereas steps 2.1 to 2.10 is a refinement of step 2, which is calculating the 2's complement 8-bit binary sequence. So what we're going to do is get a denary number between -1 and -127. So remember how you got a denary number before. Okay, if I make it an integer and ask them, a denary number, and I'm going to put in -1 to -127. Okay, so I've got a little meaningful comment there. But of course, at National 5, you were asked to do input validation. So we implement our input validation. So we say, well, denary. Now, normally it would be like if it's less than 0 or denary is greater than 255. That's probably where you're coming from with task 2. However, if you think about negative numbers, you've got to start on the left-hand side with the lowest possible negative number, which is -127, and then greater than the highest possible number, which is -1. Okay, of course, you could just switch the arrows and do -1 there, or less than -127 there. But it's up to you. But remember, -1 is actually the highest number in your range. If it's less than 127 or higher than -1, then we're going to display an error. Just say error, try again. Okay, always remember to write that error. Okay, because if you don't write the error, then it's not really validating the input. It's just continually asking you the same question and there's no feedback to the user. So even just saying error, try again is good practice. Line 4 is exactly the same as line 2. I just copied and pasted it. And by the time the user gets to my cursor at line 6, guaranteed you're going to have a denary number, an integer number between -127 and -1. So we're ready for step 2. Step 2 is calculating the 2's complement 8-bit binary sequence. Okay, so if you remember, there's multiple ways of calculating the positive 8-bit binary sequence, but I'm going to go for a fast way, okay? So we know that the denary number is negative, okay? So I'm going to create something called new denary, and I'm going to use a function called abs. And abs, as it says, Replic's very handy here, it returns the absolute value of the argument. So basically, it takes away the minus sign from the number. And if it's a positive number, it returns exactly the same number, okay? So new denary is the absolute value of denary. So if you've typed in minus 42, this line makes it 42. And so I've got a new denary, which is an integer number, and I'm going to calculate the positive 8-bit binary sequence. Okay, so I'll say pos binary, oops, can't type, equal to, and remember, you can make an 8-bit binary sequence using format. Remember, we printed it out in A3. All you need to do is pass in an integer, and then you give it the format that you want it to be represented as. And it works with string assignment or variable assignment as well. So pos binary will now hold a value, which is the binary sequence of the positive denary number. Now you might have gone with the divider one that we did in task A1 and A2, but there's a shortcut, okay? As long as you know how to do it and you can kind of work it out for yourself, there's nothing wrong with kind of shortcutting and making use of features. Just remember that that is not true when you're doing standard algorithms. So like in NAT5, there were 4 steps, okay, to implementing an input validation. With your higher level standard algorithms, you've also got to stick to that kind of standard way of forming it, hence the word standard. So we've worked out our binary, positive 8-bit binary sequence there, and then we're going to just follow the next steps. So the next step is to set new output. So it's in brand new variable, we're going to set it to blank, okay? And then we're going to loop for each character in the sequence. Now think about, oh, I wish I had a Toblerone, that would be handy. Think about your array of your binary sequence as being, your string, your binary sequence, being a bit like having lots of numbers. So if I just kind of stick this to a booklet like this, okay, so we've got 0 and 1 and so on, okay. Each element in our string, so let's say there's 2 bits in our binary sequence, the leftmost character in the string can be accessed in exactly the same way as you access each element of a one-dimensional array in Python, okay? So we can say, show me the character at position 0 in the string called pos binary, okay? And that will, so pos binary open square bracket 0 will give us that digit, okay? Pos binary open brackets 1 close brackets will give us this position, and if there's another one, pos binary open brackets 2 would give us the 3rd position in the string, etc. So we can use a loop to get through each character in the sequence, and that's what step 2.3 is all about. So we're just going to say for index in range 0 to 8, because we know it's going to have 8 bits, because that's what we did in line 10. We're then going to just test, and I've got to tab in a little bit, and say if the current character, so this is the bit where you're treating a string, pos binary, a bit like an array. So you open square brackets and you put in the keyword index. So that will loop around, it'll say pos binary 0, pos binary 1, pos binary 2, 3, 4, 5, 6, 7, and that's it. We're saying if it's equal to, so double equals in Python, to the string 1, remember it's a string, so it's a character. And then 2.5 says, if that's true, then set new output to be whatever new output was before, plus 0. Okay, so it adds a 0 to whatever new output was before. And then we're going to say else. So if it's not 1, it's got to be 0. We're assuming that the binary sequence is correct. And then else, it's going to be a 0 in its pos binary index. So we can flip it and add 1 to the binary sequence for new output, okay? End if, Python doesn't have an end if, end loop. Python doesn't have an end loop. So at this point, line 25, we have a variable called new output, which is the flipped binary sequence of the positive binary value of the negative value that you started with. Okay, and I'll show it in a second. So at this point, we're just going to print out new output. So I'm going to prove to you that this is working in the right way. I'm just going to concatenate the word flip so you know what we're looking at, and then I'm going to go up to line 10 and I'm going to print out pause binary, which is I'll just say pause. Okay, and I'll just print out pause binary. So 2 strings there. So we're going to have the positive binary of the negative number that we type in, and then we're going to have the flipped one. So you should see the binary sequence, and then every 0 should become a 1 and every 1 should become a 0. Okay, and if we've got that far, we are good. So let's run the code and see what happens. So we're going to enter denary number. So firstly, I always try with a positive number, something outside the range. So it says error, try again. So I'll just try it one more time because I don't trust it. Okay, and this time it didn't like it, it let me move on. So there's an issue that we've got to resolve. However, look what happened. It calculated 25 as 00011,001 because abs just takes away the sign if it's a negative number. So it actually, this part worked. So let's test the flip. Okay, so the flip says 111,00110. So that is the actual, it's the reverse of the pause line. So even though my logic didn't work there, it's actually calculated pause and flip. And then it says error, try again. So interesting. Let's just run that code again, see if we can replicate that error. So type in 5 and I'll type in 25. Still does it. Okay, so let's have a quick look at the code, because obviously there is a little indent problem here, which is entirely possible. So yeah, there we go. Now, as you can see, line 9 and 10 is actually tabbed in too far. So it's actually in line with lines 4 and 5. So just be careful of that. When you've got lots of comments, it's very easy to forget where the tab should be. Okay, so this needs to go back one. So it's in line with step 2. And that's just because I tabbed in the individual breakdown steps. Okay, so I'll take in 2.1 as well there. So it's all in the same line. Just remember, if you've tabbed it in for any other reason, you just remember and just take it back 1, not all the way back, or you see, like that, or you'll end up with lots of other issues. Okay, and then when we get to this point, we should be back there because our loop has finished. So there we go. That's a good error to see in action. Wasn't deliberate, by the way. So we're going to run it again. So we're going to say 5 this time, and then we're going to try again with 25. This time it should say error, try again. Okay, that's good. So I'm going to say -5 this time. Okay, so -5. So we know that 5 in positive, so positive 5 in binary is 101. So we've got our 5 zeros and then 101, and then just make sure that we've flipped it properly. So 0 and 1, 0 becomes 1, and then the third last and the last digit has changed from a 1 to a 0. So our flip function works fine. Run it one more time. I'm happy with the input validation now, so I'll do -25 just to see that that works. So yeah, so it works at the positive and then it flips it. Okay, so I'm confident that we've resolved that issue, and it was just due to those that extra tab, and due to the fact that I wasn't paying attention to where my comments were. Okay, but that can happen to anyone. So we're at a good point. We're now at step 210. Now at step 210, we're adding 1. So we've done the take your negative number, make it positive, flip it was the second step, and then add 1. So we're at that add 1 step. So let's look at how we do this. Remember, keep your tabs in the right place, Mr. Simpson. So back in line with all the lines above it. It's really easy how we're going to do this. So we're going to call final binary, and we're going to use the new output. So because we generated the new output, by flipping the positive binary, we don't actually have the denary value of that yet. So we're going to work out the denary value of new output by converting it to base 2. Okay, this is really important because if we don't do that, we can't add 1. Well, we can, but we can't add 1 easily. So what you do is say final binary is equal to int new output 2, which will give us, say we typed in -1. Once it's flipped, it would be 254, because that final 1, that final digit on the right hand side would be a 0. And then we can just add 1 there. So final binary is whatever the integer value of the binary that you've flipped is plus 1. And then we're outputting the final binary sequence. And we know how to do this because we did it for every other program so far. So we're going to print format final binary, which is actually a denary value, comma 08b. Okay, which is the sort of formatting function. And we're just going to test this out. So I'll stop it and I'll try again. There we go. So we know that +5 should have an error. We're going to test +99 just in case. We'll do 25 as well, just for luck. Okay, so our logic is working now. And then we're going to say -25. Okay, we should see 3 steps come up. So our positive -25, the positive version of -25 is +25, and that is 110011. Sorry, 11001. So when we flip it, we already know that this is correct because we tested it, but we have to add 1. So I predict that the only thing that will change is that final digit, and that will become a 1. And so we've got 1110011. Okay, and that is the correct 2's complement output. So have we finished our program? We got the denary number, we calculated the 2's complement, and we output the final binary sequence. And that is your answer to A4. Remember, your answer might be slightly different to mine, but as long as it works, as long as it displays the correct binary sequence and 2's complement at the end, then you're good to go. If you've got any questions, post a comment, and either in the YouTube video or in Google Classroom, and I'm more than happy to help you out. See you in the next video.